Okay. Today I want to talk about section 11.2, like a series. This is the outline. So first, I want to talk about definition of a series. Second one, the definition of convergence and divergence of a series. Third one, what is a geometric series? First one, what is the telescoping sum? The last one is, what is the test for divergence? Today, I want to talk about these 5 things. We can start with definition of a series. So what is a series? Add the terms of an infinite sequence an from n equal to 1 to infinity, like this. a1 plus, a2 plus, a3 plus, the till an plus, keep going. So we have this notation, summation from n equal to 1 to infinity an. This is like a notation. Or just summation of an. Which is called an infinite series or just a series. How can you calculate an infinite series? This is an example. 1 over 2 plus, 1 over 4 plus, 1 over 8 plus, 1 over 16, 1 over 32, and so on. So how can you calculate this one? So the main idea is, do you know how can you solve this kind of problem? Do you have any idea? If you have any idea, could you write your answer on the chatting board? So do you have any idea? Yeah, answer is 1. Yeah, Kevin said answer is 1. You're right. How can you find 1? Could you explain a little bit more in your chatting board? If you have any answer, just to write your answer on chatting board. The main idea is, okay, we can use like a geometric series is main idea. So how can you derive a geometric series? So first, we think about the exact definition of a series. So we use this idea, use the partial sum and concept of a limit. This is a whole idea for solving this problem. So first, only add, this is like a partial sum is Sn. Sn is summation from I equal to 1 to n an, like this. So concept of limit is take limit. So what happens? So we have this result. I can write a little bit more. So here, the first, you need to calculate partial sum Sn first. The next, take limit. What's like exact meaning? This meaning is the limit n approaching infinity, summation I equal to 1 to n. The a I. This is my typo. This is not an. This is a I. This is typo. So what does it mean? So we can take limit as n approaches infinity. So what does it mean? This n is going to infinity. The exact meaning is the next one. Summation I equal to 1 to just infinity. Add the infinity many terms in a sequence, the ai. So we can replace I by n. Summation n equal to 1 to infinity a n. This is exactly here. Infinite series. So we have it. This is the whole idea. What's the idea? Find partial sum. Next, take limit. This is the whole idea for solving this problem. We can apply these 2 concepts to our problem. So how can we solve this kind of things? Let me see. This is the same example. The first one, we think about partial sum. The first one, S1. S1 is just the first term 1 over 2. The 1 over 2 is exactly same to 2 minus 1 over 2, right? Like this. What is S2? S2 is add the first two terms. 1 over 2 plus 1 over 4. You just only change it to the only one fraction by using common denominator. The common denominator of 2 and 4 is just 4. You can change the first one, 2 over 4 plus 1 over 4. So we have 3 over 4. The 3 over 4 is exactly same to 2 square minus 1 over 2 square, right? It's the same. The S3, 1 over 2 plus 1 over 4 plus 1 over 8. Just add first 3 terms. So what's that? The 1 over 2 plus 1 over 4 is previous result. So we have 3 over 4. So this is same to what? 3 over 4 plus 1 over 8. So like this. You can change it to the common denominator a. So only multiply top and bottom by 2 over 2, exactly 6 over 8 plus 1 over 8. This is 7 over 8. What's it like 7 over 8? The 7 over 8 is same to 8 minus 1 over 8. You can change it a little bit, the next one. 8 is 2 cubed minus 1 over 2 cubed. This is like a whole idea. That's 3. So next, this is the next one. S4 is same method. The 1 over 2 plus 1 over plus 1 over 80 plus 1 over 16. The 1 over 2 plus 1 over plus 1 over 8 is from the previous one, exactly 7 over 8 plus 7 over 8, 1 over 16. So like this, so we have it. The next, change it to the common denominator 16 and add it, change it to the 2 to the 4 minus 1 over 2 to the 4. We have general form. S5 is similar. So the keep going the same idea exactly. 2 to the 5 minus 1 over 2 to the 5. As Sn, Sn is 1 over 2 plus 1 over 4 plus till 1 over 2 to the n. So do you have a pattern here? This is like 5. You can change it. This is what? 5, 5. This is like 4. We have, this is 4 and 4. This is like 3. We have 3, 3. We have one good pattern. So when you replace the power by n, so we have 2 to the n minus 1 over 2 to the n. So next step, take limit of partial sum. The limit of partial sum is the limit of 2 to the n minus 1 over 2 to the n. So how can you solve? This is exactly infinity over infinity form. You can use the, how can you solve this limit? You remember? How can you solve the section 11.1? Do you know? How can you solve the limit 2 to the n minus 1 over 2 to the n? How can you solve this problem? Yes, L'Hopital's rule, you're right. Did you learn relative ratio growth? Do you know relative ratio growth? Do you know this one? Did you learn this one? Do you know this one? Okay, good. So you can learn this kind of things. Either is very simple. You can compare 2 to the n and 1. The 2 to the n is going to infinity. The 1 is just a constant. Constant doesn't affect forgetting infinite values. Ignore constant. So next, cross out 2 to the n. Answer is 1. So what is answer? 1. That's it. So we have summation is 1. What's like main idea? Just to use partial sum, and limit. This is the whole idea. I'm going to summarize this kind of thing, the generalize this one. Here, we only use partial sums and concept of limit. This is the whole idea. So like this, S1 is only add one term. So like this, S2 is add first two terms. Summation from I equal to 1 to 2 AI. S3 is A1 plus A2 plus A3. Add first three terms. S4 is 4 terms. The summation from I equal to 1 to 4 AI. The general form is A1 plus A2 plus A3 till AN. Summation I equal to 1 to N AI. So what's it like next step? You can take what? The limit. So what happens? Take limit. So we have summation I equal to 1 to N is like AI. It's exactly same to what? Sn. Take what? Limit. N approaches infinity. Take limit. N approaches infinity. So what's that? This N is going to positive infinity. You can replace summation I equal to 1 to infinity AI. Only replace I by N. It doesn't matter. Summation N equal to 1 to infinity A sub 2N. That's it. So how can you find summation of AN? This is the idea. Take partial sum, take limit. This is the whole idea. So this is very important. You can use this one. So you got it? So far, do you have any question so far? It's good? It's good? Okay, the more question, I going to next one. So like this is my previous explanation. So we have two definition conversion. What does it mean? Series converges. What's that? Limit exists. What's it like limit exists? This limit value is, what does it mean? Limit exists. Limit value is finite. The limit value is finite. We call series converges. What's it like diverges? Limit does not exist. Limit value does not exist. What is the non-existence of limit? So we have three possibilities: infinity, minus infinity, sometimes oscillating infinity many times. Oscillating infinity many times. This is divergent. This is divergent. So we have three possibilities like this. So summarize. This is partial sum. Summation I equal to 1 to N AI. We use Sn, this notation. Was it like whole series? The summation from N equal to 1 to infinity An. How can you calculate? The take partial sum, take limit. You can change partial sum by Sn. Limit of Sn as N approach infinity. This is like exact the definition of the series. Was conversion? Limit exists. Limit value is finite. Limit is divergent. Series is divergent. If the limit does not exist, what is the non-existence of limit? Limit value is infinity, negative infinity, sometimes oscillating infinity many times. These oscillating things is not going to one number, right? Like this. The next one, geometric series. What's it like a geometric series? Here, A plus, AR plus, AR square plus, ARQ plus, till AR to N minus 1 plus, and so on. We call geometric series. How can you find the second term from the first one? The first term times R. How can you find third term from the second term? Times R. How can you find the first term from the third term? Times R. So next one is times R. So like this. So we call geometric series. That's right. In this case, we call what's R? We have common ratio. We call this is common ratio. So like this. That's right. Do you remember our previous example? 1 plus, the 1 over 2 plus 1 over 4 plus 1 over 8 plus, keep going, 1 over 2 to the n. So like this. This is exactly geometric series. Geometric series. The y, the here. How can you find 1 over 4 from the first term? Just 1 over 2 times 1 over 2, we have 1 over 4. How can you find the 1 over 8 from the 1 over 4? Same. 1 over 4 times 1 over 2. The next term is times 1 over 2. So we call this 1 over 2 common ratio. Common ratio. We call common ratio. So we use notation R, like this. Right? So we can use simple notation, summation notation. Summation from n equal to 1 to infinity, a times r to the n minus 1. So a is not equal to 0. So what's it like Sn? A plus ar squared plus till ar to the n minus 1. It's right. Only added first n terms. This is Sn. So I want to check the geometric series is convergent or divergent. Was it like our previous example? The 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 and so on. What is the answer? This value is 1. We have a finite number. In this case, the series is convergent to 1 from the previous example. In general, sometimes convergent, sometimes divergent, depending on the common ratio R. So case 1, common ratio R equals 1. What happens? So what do you think? Common ratio R equals 1. The geometric series is convergent or divergent. What does it mean, the convergent? The series is finite. The series is infinite, negative infinity, the oscillating, the like series is divergent. What is your answer of this one? The R equals 1. The geometric series is convergent or divergent. Peter said divergent. Calvin said divergent. Do you have the more opinions? All of you guys agree with the divergence result. So what do you think? Okay, Imani said divergent. Okay, good. This is like a divergent. Why? Let me see. You think about this one. What's that saying? Like this, because you plug 1 into here. R equals 1, R equals 1, R equals 1. How many n? We have n n's. That's right. Only a plus, a plus, a plus, a. So answer is n times a. Next, take what? Limit. Limit of partial sum. So limit of n is infinity, 1 negative infinity. Does it make sense? Here, the y, the limit of n approach infinity, n times a. So what does it mean? This n is approach is positive infinity. Was it like a? A has two possibilities, positive number or negative number. So infinity times positive number is going to positive infinity. Infinity times negative number is going to negative infinity. We have two possible answers, always divergent. This case one. Second case, r equals to -1. What do you think? Convergent or divergent? So we can plug r equals to -1 into r. So what happens? The Peter said like divergent. So what do you think? You have the same answers? Divergent. Divergent? Okay, I'm gonna check. So like this. The Sn is, this one is right. You plug -1 into r. You plug -1 into r. You plug -1 into r. So we have this one. So first one, what's S1? Just add first term A. What's S2? Add two terms. A minus A is 0. What's S3? Add three terms. A minus A plus A. A is cancelled, just A. N is what happens? So we can think about some pattern. What happens? S1, S2, S3, S4, S5. As S1, A. S2 is 0. As 3, A. S4 is 0. S5 is A. What's that? So we have this kind of result. The oscillating infinity many times, right? A0, 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 just oscillating infinity many times. The limit of Sn does not exist. Sn diverges. Yeah, diverges. So third case is R is not equal to 1, R is non-negative 1. So Sn is A plus AR plus AR squared plus AR to the n minus 2 plus AR to the n minus 1. You can calculate R times Sn is like this. Does it make sense? Like this. You can multiply the both sides by R. Here, the both sides by the R. The R times A is first term. The R times AR is second term. R times AR squared is here. A times R cubed. So here, R times A times R minus 1 is A times R and R to the n minus 1. Last one, R times A R to the n minus 1 is exactly AR. So we have R times Sn is second one. The next is subtract. What happens? We have it. We can do it like this. Only subtract. Two things. You just only subtract. The Sn minus R Sn left hand side is here. Next is AR minus AR cancelled. AR squared minus AR squared cancelled. The middle one all cancelled, cancel, cancelled, like this one. What's the remaining things here? The A minus AR to the n. So we have it. Just this one. The next is fact out. Fact out Sn 1 minus R times Sn. Fact out A times 1 minus R to the n. The next is divide by 1 minus R crossed out. Sn is A times 1 minus R to the n over 1 minus R. So we have it. So what's the next step? You can take the limit of An, is right? The limit of An. So we think about two more cases. So from the third case, what's that? So we have like this. Except minus 1, the except 1. So we think about middle range first. The middle range is R is between -1 and 1. So what happens? The limit of Sn. What's the limit of Sn? You take limit n approaches infinity. Yeah, Eric said conversion. Yeah, thank you. This is a times 1 minus r to the n over 1 minus r. So we think about the r is between -1 and 1. What happens? R to the n, right here. What's the limit? N approaches infinity, r to the n. Only this part. What do you think? The r is between -1 and 1. What is limit of r to the n? So Peter said 0. 0 is right? Yes. The one example is r is like did you learn this stuff in section 11.0, I think? The one example, r equals 1/2, the limit of n approaching infinity, r to the n is 1 over 2 to the power n. So what happens? Plug n, the 1 into n, 2 into n, 3 into n. The 1 over 2 to the 1 is 1 over 2. 1 over 2 square is 1 over 4. 1 over 2 cube is 1 over 8. 1 over 16. Decreasing, 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 going to 0. So this is going to 0. So here, this part is going to 0. But the remaining things, a over 1 minus r. Yes, we have finite number conversion. It's like first result. So like this. Second one. What's that? R is this one. Take limit. Take limit of Sn. So same. You can calculate limit of Rn first. So this is divergent, right? So in this case, what happens? Limit of Rn, you can calculate limit n approach infinity, the r to the n. So we think about r is like a greater than 1, I can choose r equal to 2. You plug 2 into here, limit n approach infinity, this r to the n. The 2 to the n is going to infinity, like divergent. Was it like negative number? I can choose -2. We calculate the limit n approach infinity, the -2 to the n. What happens? Plug 1, -2. Plug 2, 4. Plug 3, -8. Plug 4, 16. What happens? -2, 4, -8, 16, -32, +64. What's that? Oscillating infinity many times. So divergent. Divergent. Was it like a conclusion? Sn is divergent, right? So this part is divergent. Automatically, this whole thing is also divergent. So we have this result. We can combine case 1, case 2, case 3. We have one good result. The geometric series is convergent if absolute value of r is less than 1. Was it this case? So this is equivalent to r is between -1 and 1, the conversion. The conversion number is a over 1 minus r. This a is the first term, is right? This a is exactly first term. This r is like common ratio, the common ratio. The absolute value of r is greater than or equal to 1. The geometric series is divergent. What's that? So this inequality is exactly same to the r is less than or equal to -1, or the r is greater than or equal to 1, always divergent result. So we have name A, first term, R, common ratio. Right? This is the idea. How can you know convergent or divergent? Common ratio, absolute value of common ratio is less than 1, convergent. Common ratio, absolute value of common ratio is greater than or equal to 1, always divergent. This is idea of checking if series, the geometric series is convergent or divergent. This problem. So this is a geometric series, is it right? The geometric series. Yes. This is a geometric series. What is the common ratio? What is the common ratio? Could you write new answer of a common ratio? The negative 2/3. Okay, the negative 2/3. Is it right? Negative 2/3. The negative 2/3. Is it right? Okay. So yep. Okay, the negative 2/3. Let me see. This is common ratio. So we can use this idea. The idea is very simple. How can you find negative 10 over 3 from the 5? Just to multiply 5 by negative 2/3, negative 10/3. Negative 10/3 times negative 2/3 is 20 over 9. The 20 over 9 times negative 2/3 minus 40 over 27. Yes, this is geometric series. What's R? R is negative 2/3. So convergent or divergent? Series is convergent or divergent? Eric said convergent. Elisa said convergent. The convergent. Yeah, thank you, all of you guys. Yes, convergent, because you calculate absolute value of R. This is this one, exactly 2/3. The absolute value of R is less than 1, exactly here. What's the convergent number? A over 1 minus R. So we have, what is A? What is A? A is, what is A? Yes, the first term, 5, yep. The R is common ratio, negative 2/3. So what is answer? We have convergent number A over 1 minus R. A over 1 minus R is 5 over 1 minus negative 2/3. This is a 5 over 1 plus 2/3. So simplify. The 1 plus 2/3 is 5/3. You can multiply 5 times reciprocal of denominator, 3 over 5. 5 is crossed out, 3. So what does it mean? The series converges to 3. So that's it. This is the idea. This is the idea for solving this problem. Next one. So yeah, this is explanation 3. Next one. You think about it, the second problem. What do you think? Convergent or divergent? This is geometric series, is right? So geometric series. This is geometric series. So what do you think? The Peter said like a divergent. Why? So why this series is divergent? Sure, I just wait. Convergent? y. The same equation. The divergent conversion, the y. This is geometric series depending on common ratio. The absolute value of common ratio is less than 1 conversion. The absolute value of common ratio is greater than 1 divergent. Right? This is like a whole idea. So okay, know that convergent or divergent. We try like this. Always use same concept of geometric series. Divergent. Okay, we can check together. So what's the power? Yeah, the R equals to 4 over 3 is good. Yeah, it's a good answer. Power is like 2n, power is 1 minus n. I can change power to n, so like this. So 2 squared to the power n times here only factor out 1 minus 1. So we have it. So this is 4 to the n over 3 to the n minus 1, is right? This is change for 4 to the n, change it to the denominator. Next, the 4 to the n is the same to what? The 4 to the n minus 1 times 4 to the 1. You can change it. The 4 to the 1 is here, 4 to the n minus 1, 3 to the n minus 1 is here. So like this. So what's the common ratio? 4 over 3. 4 over 3 is exactly R. This is R. R is 4 over 3. Take absolute value. 4 over 3 is greater than or equal to 1. Answer is divergent. Divergent. This is idea. Next one. 1.24 and dash it. Right, upper line. The exact meaning is 1.2444444, like this kind of things. So I'm gonna change this one as a ratio of integers. How can do that? I wanna use geometric series. We can change it. 1.2444 is like this. 1.2 plus 0.04, 0.004, 0.0004, and so on. It's right. You can change it like this. This is a geometric series. This is geometric series. So what do you think? The geometric series? Yes. Yes. What's the common ratio? 2/5. Yes, 2/5. You're right. So here, how can you know that the 1.2 and 0.04 we don't have any relation? So you have to keep 1.2. You can keep 1.2. So from the second one, how can you find 0.004 times 0.1? How can you find next one? Times 0.1. Next one is times 0.1, and so on. So what's that? 0.1 is common ratio. The common ratio, take absolute value. Absolute value of 0.1 is just 0.1. Always less than 1. So we have conversion result. So let me see. How can you do that? You can change it like this. So you can keep 1.2. So we don't have any relation. 1.2. In this case, what is A? This one is A. So this one is like R. The plus A over 1 minus R. So we have 1.2 plus. A is 0.04 over 1 minus 0.1. So this is same to 1.2 plus 0.04, 0.04 over 0.9, is right? So this is not our answer. Change it to the what? Ratio of integers. You can change the ratio 1.2. 1.2 is 12 over 10 plus. Was it like 0.04 or 0.9? I'm going to change this one to the integer. So just multiply top and bottom by the 100. This is same to 12 over 10 plus the 0.04 times 100 is 4. 0.9 times 100 is 90. The next combine. 12 over 10 plus 4 over 90. You can change the first one to the common denominator, 90. Just multiply top and bottom by 9. So 12 times 9 is 108 over 90 plus 4 over 90. Only add the numerators, 112 over 90. This is not a final, simplify. 2 is a common factor, cross out 2, so change 56. This is 45. The final answer is 56 over 45. So that's it. This is the whole idea for solving this problem. Does it make sense? Does it make sense? This is the idea. Do we have it like this? So next example. Show that series is conversion and find its sum. This is not a geometric series. How can you solve this problem? This is note. This is not a geometric series, so go back to the definition of a conversion series. Summation from n equal to 1 to infinity, an is the change limit of the partial sum. Limit summation I equal to 1 to n ai as n approaches infinity. The partial sum is like Sn. So this is the idea. What is Sn? Summation I equal to 1 to n, 1 over I plus 1 is right. So only replace, this is I. Change n. This is like a partial sum. So like this, so we have it. So like this, right? So like this. How can you calculate? So we use partial fraction decomposition. This is the idea. What's like a partial fraction decomposition? The 1 over I times I plus 1. So we can borrow the one concept is like this. A over I plus B over I plus 1. You can multiply by using common denominator I times I plus 1. The first one, we need I plus 1. A of I times I plus 1 over I plus 1. Second one is B over I plus 1 times I of I. So simplify, right? Because, so what's this one? This is AI plus A times 1 is just A plus B times I is BI. And combine. AI plus BI is A plus B times I. A is constant. But next, you have to compare numerator. A plus BI plus A and 1. You can compare what is coefficient of I, what is constant part A, what is A plus B, and what is A. What's A plus B? What's A plus B? You can compare one with A plus BI plus A. What is A plus A? You know, A plus B? What's A plus B? So do you have any idea what is A plus B? So you can compare the like this. So 1 equals A plus B times I plus A. Oh yeah, the two guys said 0. Yes. But here, this is, why is it like I? We don't have I term on the left-hand side. Exact meaning is 0 times I plus 1 equals A plus BI plus A. The 0 is A plus B. So we have 0. What is A? A is 1. So we have this result. You can plug A equals 1 into A. We have 1 plus B equal to 0. Subtract 1 from both sides. The P equals minus 1. We have it. A equals 1, P equals minus 1. Does it make sense? The next, you plug these numbers into here. You plug right here. So can you say great? We have it. So like this, because you plug, oh, not 0I. Here, as I said before, one is A plus BI plus A. 0 equals A plus B times I plus, oh, sorry, this is 1. Sorry, 1. So 1 equals A plus B times I. So that's A is constant 1, very clear. What's that? It's very simple. This A plus B. This A plus B is exactly 0. The 0 times I is always 0. This part is gone. So A plus B is 0 because we don't have it I part on the left-hand side. We don't have it I part on the left-hand side. This is the reason. No. A plus B is 1 minus AI. No. Yeah. This is different. Yeah. So one more example is you can replace I by X. So what do you think here? You can replace I by X. So what's that? 1 equals A plus B. The whole times X plus A. The A is constant, 1, very clear. Was it like A plus B times X? So here we know 0 times X. The 0 times X is like 0. You can compare 0 is coefficient of X. A plus B is coefficient of X. So exactly A plus B equal to 0. So this is idea. Don't use A plus B equals 1 minus A over I. No, don't use it. So we cannot find anything. Okay, the next one. Did you get, Kylie? Did you get your answer from my explanation? It's good? Okay, so one more example. So let me see. The what is, so like this, compare. What is A plus B? What is A plus B? So could you answer my question? What is A plus B? So do you have it? Answer 5I plus 2 equals A plus BI plus B. Yes, 5. Just coefficient of I is 5. Yeah, it's 5. What's B? What's B? Yes, 2. Constant part. Yes, 2. Constant part. So similar. So from here, you can compare the 1 and A plus BI plus A. So 1 doesn't have I part. Doesn't have I part. What does it mean? 0 times I plus 1. It doesn't matter. The 0 times I equals 1. So we can compare. The 0 is A plus B. The 1 is the A. The I is just variable. I is a variable. So this is the reason. So very similar to my previous example. So we don't have item, always the coefficient of I is 0, the 0. This is the key part. This is a very important thing. So you just understand this part, you can solve this kind of problem, Okay, the next is, so here, you can plug A equal to 1 into here, A equal to 1, the B equals -1 into here. So we have it like this. So far, take a summation, is right? This part is this one. Take a summation. We have partial sum. You plug 1 into I, 1 minus 1 over 2. You plug 2, 1 over 2 minus 1/3. Plug 3 into I, 1/3 minus 1 over 4, and so on. Last one, you plug n into the I. The last one is 1 over n minus 1 over n plus 1. So we have it because 1 over 2 is cancelled. 1 over 3 is cancelled. 1 over 4 is cancelled. The 1 over n is cancelled from the previous one. So remaining part, it makes sense? Because the previous one is exactly 1 over n minus 1 minus 1 over n. So 1 over n is cancelled here. So this one is cancelled, the previous one, and so on. The remaining term is 1n minus 1 over n plus 1. Then what's the last step? Take limit of partial sum. What is the answer? What's the limit of 1 minus 1 over n plus 1? What is the answer? So what is the answer? Is 1, is it right? Yes. This is going to 0, just to 1. Just 1. So that's it. So series is conversion to 1. What's that? The term cancelled in pairs, we call telescoping sum. So this example we call telescoping sum. This is one good method for solving this problem. The next is the harmonic series. What's a harmonic series? Summation from n equal to 1 to infinity, 1 over n equals 1 plus 1 over 2 plus 1/3, 1 over 4, and so on. We call harmonic series. The harmonic series is always divergent. This is the reason. What's S2? 1 plus 1 over 2. Right? Add the first two terms. What's like S4? You add 4 terms. The 4 terms. So I can replace, you can keep 1 plus 1 over 2. You can replace 1 over 3 by 1 over 4. 1 over 3 by 1 over 4. This is left-hand side and right-hand side. Which one is bigger? Left-hand side or right-hand side? Which one is bigger? The left-hand side is bigger or right-hand side is bigger? The left is bigger? Yes, because the 1/3, 1 over 4, the 1/3 is bigger. So we have like this, is right? So we have it like this. So what is 1 over 4 plus 1 over 4? 1 over 4 plus 1 over 4 is 1 over 2. You add these two things, 1 plus 2 over 2. As A, so we can use same idea. You can replace 1 plus 1 over 2, replace 1/3 by 1 over 4. Replace 1 over 5 by 1 over 8. 1 over 6 by 1 over 8. 1 over 7 by 1 over 8. And 1 over 8. So what happens? 1 over 3 is greater than 1 over 4. 1 over 5 is greater than 1 over 8. 1 over 6 is greater than 1 over 8. 1 over 7 is greater than 1 over 8. What does it mean? top one is greater than bottom one. So like this, right? So we have it. And simplify. This is 1 over 2. The 1 over 2 plus 1 over 4 is 1 over 2. You add 4, 1 over 8, it's 1 over 2. We have 1 plus 3 over 2. So let me see. Do you have one pattern? This is like 2 cube. This is 2 square. So what happens? S to the 2 to the 4. So we can use same method, the greater than, you can replace like this. This power 3 is exactly same to 3. Power 2 is exactly same to here, right? So what does it mean? This is 1 plus 4 over 2. So keep going. What is S to the 2 to the n? Greater than 1 plus n over 2. This is like a whole idea, like this. So this is 1 plus n over 2. Take limit. So what happens? Take limit, n approach infinity, and take limit, n approach infinity. N is going to infinity, the n over 2 is going to infinity. 1 plus infinity is infinity. So what does it mean? Limit of s to 2n is greater than infinity. So we have infinity, right? Infinity. So partial sum approach infinity. So this is also approaches same number infinity. That's it. So always divergent. Always divergent. Harmonic series is always divergent, approach to positive infinity. So next tip. So we have the one theorem. The summation an is convergent. The limit of an is always 0. Always 0. So proof. Sn is a1 plus a2 plus a3. The keep going an minus 1 an. What is Sn minus 1? Just add first n minus 1 terms. A1 plus, A2 plus, A3 plus till an minus 1. Next, subtract. So what happens when you subtract this one? Subtract, cancelled, 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 cancelled. Remaining term is just an. So we have it like this. It's good. Here, summation of an is a limit of summation of partial sum. This is the definition. The limit of Sn. So we have S. So because we have the assumption. Summation of an conversion converge to some number. We don't know, but some number. This is true. The next n is approaching infinity, n minus 1 approaching infinity. Usually Sn minus 1 approaches S, Sn minus 1 approaches S. Does it make sense? Right? Here. This is n is approaching infinity. So S infinity is going to S. The n minus 1 approaches infinity, S infinity is going to S. The same number. Is it right? That makes sense? The one example is, I'm going to give one example. Sn is 1 over n. What's the limit of Sn? N approaching infinity. Sn is limit of n approaching infinity. The 1 over n, we have 0. What is S sub 10 minus 1? Just 1 over n minus 1. What is the limit of n approaching infinity? Sn minus 1. The limit of 1 over n minus 1 as n approaches infinity. So we have same number 0. This is true. The limit of Sn approaches S, Sn minus 1 approaches same number S. This is very true. Very true. The next thing, take limit of an. Here, take limit of both sides. Take limit of both sides here. Take limit. Take limit. Take limit of both sides. You can distribute limit. So what's that? Limit of Sn is S. Limit of Sn minus 1 is also S. S minus S is 0. We have it, right? So we have the limit of an is going to 0. It's good? I want to give one example here. So if summation n equaled 1 to infinity, an equaled 10 is 10. So find limit n approaches infinity, an plus 2 over 4. So what is the answer? So could you write your answer? Could you write your answer on the chatting board? What do you think? What is the answer of this question? You think about it. 0, 0, 0, 3, 3, 3, 0, 3. So which one? So what do you think? 0 or 3? Let me see. Here. This is series. Series is what? Conversion. Here. Series is conversion. What is limit of an? 0. This is key. So how can you calculate? So an approaches 0. Exactly. 0 plus 2 over 4 is 1 over 2. So really be careful. This is the answer. Yep. The 1 over 2. The 1 over 2. It's good. So this is the one problem by using theorem. So this statement is true or false. The limit of an equal to 0, summation of an is conversion. True or false? What do you think? True or false? So what do you think? So true or false? What do you think? This statement is true or false? The limit of an equal to 0, summation of an is conversion. What do you think? True, false, true, true, false, true. Let me see. Remember, so we can write an equals 1 over n. What's like the limit of an? Limit of an is limit of 1 over n is approaches 0. What do you think? Summation n equal to 1 to infinity an is summation from n equal to 1 to infinity 1 over n. The harmonic series is convergent or divergent. Remember? So we have a result from the previous example. The harmonic series is what? Always infinity. Yeah, divergent. The divergent. No. Answer is first. The first. Right? This is the first. We have good counter example. The harmonic series. So only this case is true. So one more. So we can use the contraposition in geometry. So we have one more important result. Test for divergence. If limit of an does not exist, limit of an is not equal to 0, what's the conclusion? Series is always divergent. Always divergent. This is like a key. So let me see. What happens this series? Convergent or divergent? This is always divergent. I want to use test for divergence. Calculate limit of an. Calculate limit of an. So how can you calculate? we can use relative ratio growth. You have to ignore lower terms. You can cross out n squared, 2/3. 2/3 is non-zero. What is the answer? Series is divergent by using test for divergence. That's it. This is the idea. The next one, we have one good theorem of summation. Two series are convergent. Also summation of C times AN, summation AN plus BN, summation AN minus BN, always conversion. So how can you calculate summation n equal to 1 to infinity? Take out C. How can you find summation AN plus BN? Distribute summation. How can you calculate summation from n equal to 1 to infinity AN minus BN? Distribute summation. The proof is not difficult. We can just skip the proof. So only think about this one. Here, take out C. Distribute summation. Distribute summation. So what is this one? This is true or not? What do you think? True or false? So this statement is true or false? Could you run your answer? The statement is true or false? False? Did you write false? Yeah, false. Really be careful. No, don't do that. Don't distribute summation from the product. Fraction, same. Summation AN over BN is not equal to summation AN over summation BN. No, don't distribute summation. When do you distribute summation? Just addition or subtraction. Always distribute summation from summation. So don't distribute summation for product and quotient. No, don't do that. So next one. This is one example. Find the sum of the series. So can you do ABN? What does it mean the ABN? Oh, this is like, we don't have this notation. This is under, I totally understand this notation. So we don't use the next one. No, so we don't use, this is not sequence notation. This is not a sequence notation. This is not a sequence notation. We don't use. Yeah, we don't use. Yeah, just only use AN or BN. We don't use A over B to the N. We don't use this. Yeah. So next one. Here, what's the best way? Yes, distribute summation. Right? So first one, how can you calculate? So the take out 3, so we have this form. The next second one, we use geometric series, right? So how can you do that? This is same too. You plug 1 like this, plug 2 like this, plug 3 like this. So exactly geometric series. Geometric series. What is A? Here, what is A? Of a second series, what is A? Yep, 1/3. What is R? The 1/3 again, is right? Yes. How can you find the 1/3 square? First one times 1/3. How can you find the third one? Second one times 1/3 and so on. Is right? So this is 1/3. The absolute value of 1/3 is less than 1. So we have convergent result. So what is summation n equal to 1 to infinity 1 over 3 to the n? So we can use formula a over 1 minus r, exactly 1/3 over 1 minus 1/3. We have 1/3 over 2/3. The 1/3 times reciprocal of 2/3 is 3 over 2. 3 is crossed out. Final answer is 1 over 2. So we calculate second, right? The second series. Second series is 1 over 2. How can you find first one? The bottom one is the product of two linear functions. We have to use telescopic sum. Telescopic sum. This is idea. Telescopic sum. This is idea. This is like a result. How can you find the first one? You can change limit summation I equal to 1 to n 1 over I plus 1 I plus 2. So I want to change a over I plus 1 plus b over I plus 2. The first one, you multiply first one by I plus 2 because we have to make same denominator. Second one, b over I plus 2 times I plus 1 over I plus 1. So distribute ai plus 2a. Distribute bi plus b. Yes, the telescoping sum is exactly partial fraction decomposition. This is the idea, yes. So we can borrow concept in the section 7.4 or something like that. Yeah, you're right. Yeah, it's a good point. So combine. The AI plus BI is A plus BI. The 2A plus B is the here. The next two, compare the same things. Is right? What's the numerator? 1. 1 equals this whole thing. A plus B I plus 2A plus B. The same. The left-hand side doesn't have item. What does it mean? You add 0 times variable I. The next, compare coefficient of I. The coefficient of I, A plus B equal 0. The 2A plus B is 1. The 2A plus B equals 1. How can you find A and B? This is the idea. I just only subtract. A minus 2A is negative A. B minus B is gone. The 0 minus 1 is minus 1. So we have the A equals 1. Right? So you plug A equals 1 into here. So we have 1 plus B equals 0. Subtract 1 from both sides. B equals minus 1. You can plug AB into here. What's A? 1. P is negative 1. You plug. So we have this form. So keep going. So like this. So we have it. So like this. Next, take a summation. You just only expand. First term, 1 over 1 plus 1 is 1 over 2. Minus 1 over 1 plus 2 is 1 over 3. Second term, plug 2. 1 over 3 minus 1 over 4. You plug 3. 1 over 4 minus 1 over 5. Keep going. So what happens? Same result from the previous one. Cancelled. The all terms. Except 1 over 2 and minus 1 over n plus 2. So like this. What's the last step? Take limit of Sn. This is going to 0. We have 1 over 2. We are going back to original problem. So what happens? This one is we are previous result 1/2. So this one is 1/2. This is like a geometric series. We have it 1/2 from the previous result. So answer is 2. This is the whole idea. So we have one last theorem. Summation from n equal to capital N plus 1 to infinity. AN is conversion. Then the full series summation n equal to 1 to infinity AN is also conversion. So how can prove? Proof is like this. Summation from n equal to 1 to infinity AN is exactly same to the summation n equal to 1 to capital N AN plus summation of AN from n equal to capital N plus 1 to infinity. So what happens? The finite sum is always finite. The partial sum is here, conversion. What's it like conversion? This is finite. This is like exactly. So we have finite number plus a finite number, finite number. That's it. Series is conversion. You got it? This is all for today's lecture. If you have any question, just to ask me. So I answer your question. So if you don't have any question, you can leave this session now. Okay, this is all of today's lecture. Any question, let me know. So I can see the like chatting board. If you have any question, just ask me.